it was a good meeting.
Good job.
Awesome.
Way to go.
What kind of deal is this?
So I help businesses out with payroll, HR, 401k, different types of things like that. And so it's a small business client who has a number of employees, and I'm setting them up for payroll for this week. So it's good.
Sweet. That's awesome. All right, guys, do you want to just get started on the thing?
Let's do it.
Okay. What unit are we?
16. Sorry, I'm eating wheat things.
Oh wait, I'm in the wrong class here. Let me get into Math 221. Yeah, that's why I said unit. That probably made no sense at all.
I think 16?
Yeah. Like if that's what you mean. Okay, group meeting.
Bryce, how did you like our video from last week?
It's nice.
How long was it?
Like an hour and a half?
Yeah.
Well, we got an 88, and that's all that matters.
There you go. I know, I was watching it, and then one of you would walk away for a little bit and be like, okay, fast forward.
Yeah.
I think I even contributed to like 2 problems, so it was really good.
Yeah. No. Sweet. Yeah, sorry I was gone.
Good.
I was
Sorry.
in Pendleton, Oregon.
Oh wow.
We drove all over this last week.
Cool.
Business stuff. Anyway, all right, you guys got it open?
Yeah.
I got the first 2. 1 and 2 are true.
Awesome.
Number 3, in a pie chart, why are the slices, sectors, different sizes? Pie charts are more visually appealing than slices. When the slices are different sizes, no. Each slice represents a category, and the area of each slice represents the portion of the total occupied by the category. The size of each slice is random. The size of each slice is determined by the number of categories. The second one,
Each slice represents?
each slice represents a category.
Yeah, that sounds good to me. Okay. 4 says, how are bar charts and Pareto charts related? They are identical. Pareto charts are constructed from tossing a coin several times. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest going from left to right. That sounds correct.
Number
Right?
3.
All right, number 5. Thanks for giving me the hard. We really appreciate that.
Yeah.
We conclude that P is normally distributed. NP is equal to or greater than 10.
Nice.
And what's that?
Oh, I said nice, because we were talking about that before.
Yeah, and N times 1 minus P is equal to or greater than 10. So is P the true proportion or the sample proportion?
Is P the true and then P hat or whatever the thing is that the sample? Maybe?
I'll go for that. Let me see. I could look it up, huh? Oh, I'm looking at the wrong thing, that's why. Wait, that's the normal probability. Yeah, that's not what I want. I feel like this last week, and even today, it's just been one of those weeks and days.
Yeah. Yeah. I think our video kind of summed it up.
You know, I took the test while we were driving back. I wasn't driving, my wife was.
Oh, good. Good.
But yeah, that didn't turn out very well.
Yeah, I don't know what it is. Like, I feel like the homework and stuff I do fine, but I just feel like that stuff on the test, it was just so, I guess it had been a while, so I just kind of got really rusty on it.
Yeah.
That's
I
hard.
don't know.
All right. The sample proportion p hat is normally distributed if n is large. The true proportion mean of the random variable p hat is p. So I think P is the true proportion. Well, it
True.
says the true proportion mean of the random variable.
Wait, what?
Wait, I'm confused. Yeah, let's say true. Sounds good.
Okay.
I think that's right.
P is the true proportion. It doesn't say anything about sample size, right? I didn't hear you say anything about sample. So then what is N?
I think that's the sample size, right?
Yeah.
If N is the same thing as before, then I think it's the
Yeah,
sample
it should
size.
be the sample size.
Yeah.
Yep.
Okay, so if P is 1/4, what is the smallest N that satisfies the requirement? Okay, so 4.
Right?
So it'd be 4 times 1/4, which is 1, is greater than or equal to 10? Or would it be 40? Wait. We're plugging into that equation in problem 5, right?
Let's see here. Problem 5. So P hat is a point estimator for the true proportion P. P hat equals X over N. So the point estimator is just the event over N. So I think N is just 4. That makes sense.
Wait, I'm kind of confused because so 7's saying if P is 1/4, and so I'm plugging P into the equation in number 5.
Equation 5, right?
Gotcha.
So I think it should be 40 for N, because 40 times 1/4 is 10, so 10 is greater than or equal to 10, and 40 times 39. And then it'd be 40 times 39 is obviously greater than or equal to 10. Does that make sense?
Okay.
Maybe.
Wait, so where did you come up with 30? Oh, minus P. Okay, so, okay, that makes sense. So 1 minus.
So I could be wrong. I'm not positive, but just by because we know P is 1/4. So if we go to problem 5, it says NP is greater than 10, and N times 1 minus P is greater than or equal to 10.
Okay, yeah, 40 makes sense.
Okay.
You've convinced me.
Hopefully I'm right though.
Yeah, that makes sense. Okay, got it.
All right. Who's got 8?
I do.
I'll do 8.
Okay, go ahead. I'll do 9.
Okay.
All right, what is the following information? Use the following information to answers 8 and 9. Suppose N equals 24. So N equals 24 and P equals 0.4. What is the mean of the P with hat? What is it called?
P hat?
P hat?
Yeah. Kind of a funny name. Okay. So do we just plug this stuff into that other equation, or is there a different one we're supposed to use?
So N is 24 times 1 minus 24 minus 24 times 0.4 equals 9.6 is greater than 10. So it's 14.4 is greater than or equal to 10?
So
Is that right?
is 24 times 0.4, is that 14?
Sorry, 24 times 0.4 is 9.6.
Oh, 9.6. Okay.
So 24 minus 9.6 is 14.4 is greater than or equal to 10.
Gosh.
Well, that's what you put. So when I put that into the equation, that's what it comes up with.
Right. But I'm just wondering, is that the equation to get p hat? I don't know. I really don't know.
P.
Let me try and find that.
Now to find the standard deviation.
So if you guys hear something that sounds kind of like a motorcycle, it's our blender. So.
It's a motorcycle.
Yeah. It gets pretty loud. So.
Nice. Okay, so yeah, I'm kind of confused. Let me think here.
So it says p hat equals x over n, where x is the number of individuals with a certain characteristic. Anyway, but yeah, it says p hat equals x over n. So what does that mean?
So n is 24. P hat equals x over 24. So we would multiply 24 by p hat, right? And then we'd multiply that by x over 24. That would.
I just don't know what x equals now.
Yeah, that's what's confusing me. I found the standard deviation. That's easy.
I'm not yet. I'm not done.
Oh, let's see here. So.
When we're done, we will. When we're done, we will. When we're done, we'll go. And if you can't wait, then we won't go at all. Okay? Thank you. Okay. I can't wait till you guys get 6 and 8-year-olds. Good luck.
Thanks.
Thank you.
Oh, let's see. So we could get the z-score out of that. Maybe. Maybe not. Never mind.
I hope this doesn't sound dumb, but can't we do like normal math and just do like process of elimination and multiply x over 24 by 24? Cancel that out to find.
So.
Oh, what is the mean?
I mean, math is not my strong suit, but I mean, I'm just like, so p hat equals x over 24, right? So if we multiply x over 24 by 24, wouldn't that cross it out? And we'd be able to get at least x by itself?
Yeah, but
I guess that would still give us the same thing, huh?
Yeah.
It would give us x equals 24p, so you'd have to, yeah, I guess that wouldn't do much.
Wait a second. So here it says the sample proportion p bar is normally distributed if n is large. The true portion mean of the random variable p bar is the mean of p bar equal to p.
So is it just p?
So it might just be p. And then it says that the true standard population derivation is that, which is what I computed. So yeah, I think it's just p. I think that's why we're confusing ourselves. Because the mean value of p bar is just 0.4.
Do we need to do 0.400 or
Doesn't say to round at all.
okay?
I mean, none of them have said to round, so
True.
Yeah.
I don't think so. You know what I mean?
Yeah, I know in iLearn, and they might have changed it, you can actually like do it so that it, because you can, in the text boxes, you can tell it's a text box, which then you have to put in like the 00, or you can tell it's a number, and then it'll actually look at the number itself.
Yeah.
I'm thinking they may have changed these so they look at the number now.
Okay.
I hope.
So something to remember is that P, or the mean of P bar, is always just P. That's just how it works.
I think so. That's what it seems like the textbook is saying.
The mean of P bar. Okay. And then how do we find the standard deviation of P bar?
So the standard deviation of P bar is the square root of P times 1 minus P over N.
Okay, wait, what is it? What's the equation?
So this is just coming out of the textbook in section 3.2.2. It says the standard deviation, well actually it's in the summary at the end too, but it says standard deviation of P bar equals P times 1 minus P over N. The square root of that. So it's, here, let me do this. Can you see that?
Yes.
Oh, there you go.
So I got a calculator out. So we take this and say the square root of
And we said it was 24, right?
yeah, it is 24. All right, I got 0.1.
1 sec. So, 1 sec.
Oh, 0.4 times.
Zero 0.1, yeah, that's what I got too. So this whole P bar thing is that the equivalent of X bar? Or is that, I don't know. I think so. I think. Hopefully.
I think the other way around, which is kind of confusing. So P hat is the sample, so it's the sample probability. So that's just like saying, okay, if I want 50%, right, then I take 1 over 2, 50 over 100.
Right.
That gives you that sample proportion that you're looking for, but then you subtract it from the real proportion. And so it's kind of, we used X bar as the real proportion, and then X was the P hats. So it's kind of switched that way, but yeah, the same thing.
Same idea, just for categorical stuff.
Yeah.
Hey, so 9, it's 0.01, correct?
No, 0.1 is what I got.
0.1.
Yeah, you get no. You did it right, but now you need to take the square root of that, and that'll be 0.1. Because I think you did all of the steps except take the square root of 0.01, and then you'll get the right answer.
Okay. Okay. Yeah. Okay. I got it then. Okay. Cool.
All
Sweet.
right. So use the following information to answer questions 10 through 13. Brittany's batting average is .3. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. N equals 100 and P equals .3. What is P hat? Round to 2 decimal places. Gosh, okay.
So we want to see the probability she'll get more than 35 hits in her next 100.
So,
Oh, go ahead.
Oh, I was just going to say, so are we trying to find a z-score and then put it in the applet for this one?
I think P hat, because the X is just 35, isn't it?
Okay.
And then N is 100, so we're just taking 35 over 100.
Right. Okay.
I think.
And then, and that's the answer, it's just .35?
Yeah, because I think we find the z-score down below.
Okay.
So I think that's it, yeah. Number 11, what is the standard deviation of p-bar?
And that's that equation we just were working on, right?
I think
P
so.
times. Okay.
P times.
Sweet.
I got 0.046.
That's what I got.
It's kind of hard for me to, I know I'm going to get confused with this, but they say this is categorical information, and when I think of that, I think of more like, I don't know. It's hard for me to see this problem as that, as a categorical thing. If that makes sense, it just seems like, oh, it's
got it. Yes. All right.
nice.
Cool.
Good.
So it's 0.0. It's 0.0458 rounded to 0.046. Okay.
Exactly.
Yep. Nice work.
Nice. About freaking time, man.
Nice.
All right. What is the z-score? Number 12.
Okay. The equation for this, if you guys don't have it on you, it's p hat minus p over, and then the bottom is all, you're going to take the square root of the entire bottom. So underneath that sign, it's p times 1 minus p over n, and then you take the square root of all of the bottom. If that makes sense.
Yeah, because that's easy.
Yeah, no worries. Just, you know,
Yeah, sure.
memorize that real quick.
0.046 minus 0.3, right? Okay.
Sweet. Huh, interesting. So I got 1.091, but I also used the longer. So I basically I put in the actual equation instead of just the number that we found before.
Right.
So, because if you do that, you get like 1.08 something.
87. Yeah, that's what I did. I used the stuff we already did. So I don't know. What do they want us to do?
Probably use the long number, I'd imagine, since that's the equation.
Okay.
I don't know.
So that was 1.091?
Yeah, that's what I got.
Okay.
And then we want to take that number and throw it in the probability applet.
What'd you guys get?
So I rounded during my intermediate calculations or whatever, and I had 1.087. But if you don't do rounding, you get 1.091.
Those are good.
Okay. I'll have to go back and look at that then.
What did you get?
I didn't get that.
Something else.
But I mean, I got, so for the bottom portion, that comes out to 0.046, right?
Rounded, yeah.
Right. And then at the top of the fraction is 0.046 minus 0.3, correct?
No.
It's
Isn't
0.35.
it p hat minus p?
Well, p hat is 0.350 or whatever, and then p is 0.3, so it's.
Oh,
The
okay.
0.46 is the standard deviation of p hat.
Oh, okay. Oh man, okay. Okay, that's why I got it wrong then. So it's 0.35.
Minus 0.3 over
Minus
that.
0.3. So it comes out to 0.05. 0.05 over 0.06. Okay.
And then we just throw that in the applet.
There you go. Okay, that makes sense. I used your standard deviation on accident. Okay.
That makes sense.
Okay, cool. I got that there. So it's it's 1.086, but we're gonna say it's 1.091.
Yeah, just because if you put more precision on that number on the standard deviation, then that's
Right. Okay. Cool. All right. Cool. That makes sense then. I got that.
Sweet.
I just got to make sure I'm not doing the standard deviation next time. All right. What is the probability Brittany gets at least 35 hits in her next 100 at bats? Round to the 3 decimal places.
So we just put it in the applet, and we want to see the right-hand side, right?
Yes, I believe. So I got 0.138.
Me too.
Okay.
Okay. Is it my turn?
I'll do it.
Okay.
Did you get that, Jason?
Yeah, I did. Sorry.
If the true proportion of people who support a political candidate is p equals 0.52, and if the n sample size is 2,000 people, we need to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of p bar? Or p hat, sorry.
So it's just x over n, right? So what is x?
Well, not the standard deviation.
Oh, my bad. Yeah, sorry. It's that one formula thing.
So that would be, well, let's see. So p hat is 0.5, right? Because it's 50 over 100, 50%.
Oh, I guess so. I didn't. I was just gonna do the formula, the p times 1 minus p over n, and take the square root of that
Or what?
for the standard deviation. Because it just asks for the standard deviation, right?
Yeah. But we have, oh, we don't need p hat, do we?
No, I think they're just putting in extra information or something.
5.2. Sorry. Oh, but we will need that for the next one, I guess, when we do the z-score. Okay.
I got 0.011.
0, 1, 1. Yep. That's what I got. All right. So now when we do the z-score. Sorry, did you get that, Jason?
Yeah, I did.
So now we have to put in p hat, right?
Yeah. So now we have p hat, which is 0.5.
How do you find p hat? I'm confused on that.
So p hat is x over n, right? So it's the what did they call x? I don't remember what the term was. Bum bum bum. Where's it at? That's too high. I'm not finding it.
Is x like the probability of something happening, or?
Yeah, so it's the basically it's the sample size that you want over the total sample size, if that makes sense. So
Okay.
it's the population that is positive for whatever over the. So that's why it's categorical, because they were talking about how, like, when you do a poll, you can go and ask people, are you voting for this person? You get yes or no. And then 33 people said yes, right?
Right.
33 over the total number of people you had, and that gives you p hat. That makes sense.
Yeah.
But then you can take that with p. Well, I guess sorry, that was wrong. It's not the number of people you have. This is what you're comparing it against. So in this case, getting more than 50% means that they're probably going to win, right?
Right.
So that means 50 over 100 or 1 over 2. It doesn't really matter. They just have to get over 50%. So that's what p hat is the value, the probability that we want or that we're looking for. And then p is the real probability. So when we went and actually surveyed people, that was what we got.
Okay.
Oh!
Sorry, my wife's watching the basketball game.
Oh, I thought I was clicking for her.
Man.
Oh.
What's the score?
56-51. Golden State's up. I'm for Golden State, so
Yes.
I'm happy about that. We're blue.
No LeBron. No LeBron.
Yeah, I'm over that guy. I mean, he's good. Gotta give him that.
We don't like guys who ditch teams and come back and try to be the heroes.
Yeah.
So.
Just made some free throws, so that's good. All right. So back to math, right? So when we plug in p hat, we're going to be putting in, is it 0.5 over 2,000?
Yeah. N is 2,000.
That's minus 0.52.
P hat?
Yeah.
No.
Uh-oh. Okay.
Well, because it's saying that we want to determine that the probability will suggest the candidate is losing. So we want 50%. So we want 50% of the population, which means technically we 1,000 over
1,000.
But 1 over 2, whatever gives us 50%.
Okay.
I think. Did you guys get a number?
Sorry, not yet. And when there's these like super small numbers, I feel like I have to write them out to take the square root of it.
Yeah.
All right, I got negative 1.82.
Negative 1.82.
Or well, it's 3 spots. Negative 1.818. Is that anywhere close?
I got negative 1.790. So you took 0.5 minus 0.52.
Yeah, and then so that's negative 0.02, right?
Uh-huh.
And then
Then you divide by the standard deviation of p-bar.
yes, which before taking the square root of it, I had 0.0001248, and then I took the square root of that. Let's see what that comes up to. Which I rounded this number. It's a huge number. It's 0.011171392, and I just rounded that to 0.011. Yeah,
Well, that should be the same number as what we got in number 14.
So wait, so I got negative 0.18181818181818. Do I need to do something else?
Wait, is that what I said? I forget what I said. Dang, I had a negative.
Negative 1.818.
Yeah, is that what
you know what? Maybe I didn't square it though. Do the square root of that. But I took negative 0.2 divided by the standard deviation, which is 0.11.
Yeah.
And that's negative 0.18181818. I mean, it just keeps going.
Oh.
Yeah, that's what I got. That's what I got.
Okay.
I did it divided by 0.011171139, so that we had more precision.
Yeah, so that we all did it the same way except we rounded, so maybe we should just go with yours since it's more accurate, right? So what is it? Negative 1.91 or something?
I got negative 1.79.
Oh, 7. Negative 1.79.
1.790.
Okay.
All right. So what is the probability? What probability do you compute using the normal probability applet? P times z is greater than or equal to z, or P times z is less than or equal to z.
Oh boy. What is this big Z thing? Where'd that come from?
So I think it's saying the P is actually a function, so it's saying the probability of.
Oh.
I don't know what the little z and big Z are, though. I don't remember seeing that.
Do we plug this 1.79 thing into the applet, or?
Yeah. But since it's negative, I'm pretty sure that means that it's going to.
That it's what? Greater than or less than?
What does that mean?
Well, I got the area is 0.0367. I don't know whatever that means in this equation. I don't know.
Now, since it's asking for the probability that the candidate is losing the election, do we want the area below or above that number?
Gosh, I'm not liking this less.
No.
Hey, kind of off topic, but did you guys see the thing about like a project or something?
Yeah, I saw that. We've got a group project.
Okay. Are we supposed to start that, or is that like later on?
There's something due by the end of this week.
Wait, it is due?
I thought I saw something that there was something due the end of week 8. There was something due the end of week 10. Yeah, I'll pull that up real quick. Hold on. Pull that up. Ugh.
Oh man. So I don't know. Do you guys have any thoughts on the PZ thing? I don't.
I'm going to say the big Z is the probability that they're winning, and the little z is that they're losing.
Okay.
For the affirmative.
So then big Z is greater than or equal to little z, right?
Maybe, I don't know. I'm confused.
That makes 3 of us.
Did you guys see anything about that in the textbook? I don't remember.
I don't remember seeing any of that.
Even seeing that notation.
No.
Ah. Weird. Well, I guess we'll guess.
Okay. So the first one or the second one?
It's greater to or equal, right? The first one?
Yeah, let's go for that.
Points to the little z?
Because yeah, right. Okay. So what is the probability the survey results will show the candidate is losing even though the true P equals 0.52? So we just plug in our z-score, right? And then
yeah.
I
think if it's losing, we're looking at the area below the z-score.
I think so. And with that, though, it's only a 0.0367.
Which makes sense because the P is 0.52, which is above 50.
Yeah.
So the P is showing that they're winning, but the probability that that's incorrect, essentially, should be pretty small. That makes sense that it's either that or it's 96%.
Right, which, yeah.
That doesn't make sense because it's showing that they're winning.
So 0.037. Okay.
Wait, what is it? 0.037?
Yeah. Yep. All right. You guys ready to submit?
Let's do it.
No, we missed one.
Yeah, it's that one.
We missed the one we
Oh,
guessed.
the one we got. And it was a 50% chance.
Oh.
Wow.
All right, go down to the group project all the way at the bottom, guys.
Is it? Oh, at the very, very bottom.
Very, very bottom, yeah.
Okay.
So Saturday of this week, which is week 8, we have to design a study.
About what? Just anything?
I think
Divided
so.
into 7 sets of first. Oh my gosh.
Oh boy. So. All right. So is this something that like we have to meet extra for, or just?
Maybe we just meet during this meeting. Maybe we talk about it like after the meeting. I'm thinking.
Yeah.
Oh my gosh.
So it sounds like what we're supposed to do right now is assign everybody to a certain step of the process. And then you're basically responsible for doing that step, like for actually writing it up. But then we're supposed to talk about it as a group, like what we're doing, if that makes sense. But that person writes it.
Okay. So.
Says, for example, if you were in charge of the describe the data, you could ask one of your other group members to create and label the charts, send them to you to be drafted into the
So you're saying there's one person who writes stuff?
for each of the steps. So for step 1, designing the study, there's one person responsible for writing that section, but we're all supposed to talk about it. They just are the one that's writing it up.
Got it. And then that's what's turned in for that part of the.
Yes.
Okay, and then if you go down, it says here's a list of possible topics that you can choose from to study. Are there 1,000 chips in every bag of Chips Ahoy? So that's something you would actually have to buy a ton of bags of chips, huh?
Well, where do you see that?
Yeah, just scroll down right after step 7, where it says design the study.
Yeah.
And then it just says here's a list of possible topics that you can choose from to study. And then it's the first bullet point.
I don't see that.
What?
Do you see it, Jason?
Are you in the Word document?
Yeah.
Oh, you're in the Word document.
Oh. Oh, okay, yeah, I see it.
Okay.
I'm like, I have the Word document over, but I thought you were talking about the in iLearn. Okay. So here's the topics, Bryce. Are there 1,000 chips in every bag of Chips Ahoy?
Gotcha.
Are brand A paper towels stronger than brand B? Is there a difference in the prices of books at BYU Idaho bookstore compared to those available online? Are men or women more likely to walk on the grass if they are walking behind someone who walks on the grass? That's weird. Are the distribution of colors between plain and peanut butter M&Ms equal? Wow.
I'm not stoked on this at all.
Oh my gosh.
All right. So, okay. So if we were to do like a chip one, then a Chips Ahoy, we would have to buy like. Would we have to buy 30 bags of Chips Ahoy, or I mean?
No, just one.
Why 30?
Well, just because like.
I gotcha.
You know what I'm saying? It's to be significant, because if we just buy one, then it's like, well, it could be a fluke. It could be.
That's true.
So I don't know.
What if we bought like 2 rolls of like 2 packages of paper towels?
But how do
like
you even
have like
test?
6 in each?
Yeah, that's a good idea. I just don't know how you test which is stronger. Like that's so like.
It's so random.
Like how do you?
Wait, do we have to use one of those, or can we come up with our own?
No, we could come up with our own. It just says
And
it's
it's
a list
just
of
possible ideas, just in case you want to be, just in case you don't want to think of one.
Yeah.
Wow.
I feel like we should do something like the airplane one or something that just has data we need to go analyze.
Hey, that's a good idea. But
We can collect it by going and getting it, but
so are you saying the data, like one of the spreadsheets they provide type thing?
yeah, not use that, but go and compile that data together because we have to go collect the data. But it'll be easier to go collect the data on a website. We'll go and look at flights from different places and see what the price is, and then go do it again later. You know, that type of a study.
Yeah,
Gotcha. That's smart. Okay.
I like that.
So do you guys just I don't know if I understand this 100%, but do you guys want me to write something up or something? Or, I mean, are we doing this now or next time we meet or what?
No, I mean, it's the first portion is due this Saturday, and that's
Okay.
just the design of the study. So we have to come up with what our study is going to be, and then in week 8 and week 9, we have to collect the data,
Okay.
and then in week 11 we have to describe or discern what that data looks like.
And
Week 12 we have to make inference, and then we also have to take action, and then the last one would be due on the last week of the course, the conclusion week, which would be week 13. We'd have to make a PowerPoint presentation
okay. So
summarizing what we did, basically.
So on Saturday we need to have questions 1 through I guess 7 filled out, right? State your research question.
Yeah.
What population are you studying? Do you want me to fill that out right now? That'll be just get it done, Or should we hold off or what?
I'm thinking maybe we should right now put names on all of these, and then next time we get together, we can maybe go through that so we can think about what we want to do as our project.
Yeah, I agree.
Okay, so you're saying for like step 1 and 2 and 3 and 4, just write our name. Who's gonna write it out?
Yeah, just assign those, and then we can next time we can talk about what we want. We can think about it and then talk about what we want to do.
Gotcha. Okay.
I can do one if you guys want. I mean, I'm whatever.
Okay.
Sure.
You guys do more than me, so I feel like I gotta contribute a little bit.
I'll do number 2 then.
Are you typing it in, or you want me to type it in? You got it,
I'll put it in and just shoot you an email.
Michael, are you typing it in already, or am I doing it?
Yeah, I'll type it in.
Oh, okay.
I got it. Number 2, we're all supposed to do. You want to do number 3, describing the data?
Oh, sure.
I think I see a pattern emerging. How about I do make inferences?
Okay. And then Jason 5 and I 6, right?
That PowerPoint's gonna be. I feel like that PowerPoint's gonna be a little cumbersome, or no?
Main writer for the PowerPoint. Oh my gosh! Wow.
Yeah, I think we should all do that. But what I've noticed in other classes is that when we all do it off of different spreadsheets, or different PowerPoints, it looks horrible. So we need to. Somebody needs to put all the data in one single PowerPoint so it looks all the same.
Right.
Want me to just make a Google? Have you guys used Google presentations?
I never have, but if
Apple fans, Bryce, we don't go that far.
All right, whatever then.
No, I don't care. Whatever works.
Yeah, whatever's
is
easy.
simple.
I just know in my other classes, I do stuff and then it looks horrible, and we got a bad grade because somebody just, I don't know.
It looks all thrown together.
Yeah.
I need all the help I can get with this group project. So.
Okay.
All right. So I'll just say that we'll all work on that.
Yeah.
Yeah, I think 6 we all do that, and then obviously 7 everybody fills out an evaluation. So.
Okay, cool.
All right. So until next time, we'll just kind of think of a topic or whatever. then we'll talk about that more.
Hey, I'll do make inference and take action since those are together. 'Cause then
Which
we
one?
have like 3 sections. So 4 and 5, the make inference and take action, like those are due at the same time, and I think they're both fairly small. Like, we just have to explain how we're doing, what we're going to do with what we found out.
Okay.
I'm just thinking I could take those 2 because we have designed the study and describe the data, which I feel like are going to be a little heavier, which you guys are doing, so then I can just do those.
Yeah, why are you trying to give us all the workload?
Yeah.
Or you can do
Up,
it.
Bryce. No, that's jacked up, Bryce.
I'll let you do it if you want.
Oh no, I think my back's kind of hurt, and I don't think I'm gonna be able to do it.
Oh.
Okay, so for this week, right now, I'm not doing anything with the design and study right now, right? We're going back,
No.
we're thinking about what we're gonna do,
Yep.
and then we're good.
Sounds good. I'm just hoping that these next weeks are lighter, so we have, I hope it's not.
I don't think that's gonna be the case.
Dude, that's lame.
Okay,
Anyway.
so I talked to him yesterday. I talked to Brother Bennett yesterday because I was trying to figure out some stuff with my degree if I really needed this class or not, and unfortunately I do, so I've got to stick with it. But he said in this section or unit 2, we learned 3 things, and in the first 2 sections we've learned 3 major functions and equations. In the next 2 sections we're learning 6 more.
Oh man.
And he's like, yeah, it's kind of hard because it's going to get more confusing. And I'm like, oh, great, thank you so much. Really appreciate that. But he was super cool. I mean, just super awesome.
Good.
So he's like, if you need help, just email. And he did say this. He said, if you struggle on something on your homework, you can definitely bring it to the group and ask questions and get help.
Cool. Okay.
He just, he's not like, oh yeah, look, he wasn't saying open up the homework and do it as a group, but if you had questions, then you could go to your group and ask questions and get help from them. So.
All right. Sweet. All right. See you guys Thursday.
Until Thursday, normal time. Thanks, guys.